stop here because I need to use the calculator, because this is a calculator active problem, and you're going to kind of need to use Desmos or your calculator. Desmos, I think, is a little bit easier because you can just quickly see things. But so we have a polar function that's 1 plus 2 cosine theta, and it's graphed between 0 and 2 pi. And it says, on which of the following intervals is theta is the distance between the point and the polar coordinates and the origin decreasing. So what that means is that we're coming back to we're coming back to the origin, right? And I brought back up this graphing thing we did in class because it's really helpful, because we want to be coming back to the origin. And if we look and see, when we turn this animation on, that when we're graphing this shape here, we're starting on the axis and we're coming back. So watch what happens on this graph. So we're coming back to the origin, coming back, coming back, coming back, coming back, and now look where we are. We're back at the origin, which means we're as close as we're going to get, and we're going to start going away from it now, right? So the interval between 0 and this value, now this is a little bit different function, right? This isn't the exact same one, I don't believe. Let me go back to the question. Oh, it is. See, happens to be the exact same one, but that was by chance, right? So we're coming back to this point, and now we're going away from it to a certain point, right there, right, or a little bit before. At pi, we're now all of a sudden, we're as far away as we're going to get, and now we're going to come back closer, so that's going to be part of our answer, and then we're going to go away. Now, obviously, you don't have this animation, right, but if you can kind of think of what's happening, or we can use Desmos to graph this, right? So whether I put in both, so you can see both. We could change this if you wanted to see it in the polar coordinates, but we don't have to, because we just need to remember what's happening here is this function is decreasing and positive, right? Is decreasing and positive. I am coming back to the origin, right? And then as it becomes, as it's decreasing, still decreasing, but it's negative, decreasing and negative is nope, that's going away. And then as I am increasing in negative is coming close, right? And so I want to be, and now I'm going away. So from here, right, when I'm increasing and positive, then I'm going away again. So I need the interval from here to here, right? And this is giving me, I'm going to have to do some conversions because the answer choices, right, are all in decimals. So you're going to have to convert, but it works out, right? If I look at, what was my value here? 2 pi divided by 3, 2 pi divided by 3, 2.09. So that's what we wanted to see. All right, so just remember when you're working on these that when we can use I like using the rectangular, I like using the cosine of x because it's very easy to see that anything that is decreasing in positive is coming back to the origin. Anything that is decreasing in negative, meaning below the axis here, that's going away from the origin. Increasing and negative is coming back to the origin, and increasing and positive is going away. So let me know if that helps.